Okay, it started. Let's continue to talk about the OCL. So we will spend the last several weeks all focus on this OCL thing. Okay, what's going on here? It's quite slow. Okay, so we've gone through this. I think download it. Okay, we start talk about this OCL thing. We have 3 slides on this OCL, and some of them have the overlap, so they're not a whole lot content in the OCL, because we are not going that deep of OCL. We just learn some basic of the OCL. Then you know what is OCL, why we're using OCL, and what's what we can do, what's the capability, what we can do with OCL, and what is the basic syntax of the OCL. Okay. So OCL is a way that we can implement this MDA process. OCL. Okay, so OCL, we use OCL to put those constraints to our UML. Most of the time, UML class diagrams, maybe state diagrams. All of them, maybe if you think about the class diagram alone, it can be a powerful tool, but sometimes it's not powerful enough for us to specify a system. Especially for like this example, this is a class diagram of customer. With the class diagram, we can specify the name, the attributes, the type, all the types of these attributes, right? No problem. And we can specify even the relationship between 2 classes, like customer. Customer has another maybe a store or brand, something like that. Another class called brand, which specify the customers, the brand, the favorite brand of the customer, something like that. We can specify that with the class diagram in the UML, standard class diagram. However, if we want to specify some constraints on those attributes, there's no way to do that in traditional class diagram or in the standard class diagram. So we have to have another tool, some other tool, which can extend the functionality of UML. So OCL is one of this kind of extension. We can see that it's an extension of the UML class diagram or state diagram. So for a lot of UML diagrams. Okay, so how can we extend the functionality is we post all this. One way is we put all these constraints with the OCL statement. Okay, like this. Here the traditional diagram, we know what are the attributes, but we don't know the relationship between these attributes. Okay, so actually there is something hidden there, like the title, it can be Mr. or Mrs. and it's associated with the gender, with is male attribute. So we can specify that, like this second one. So we put the title equal to the value of title equal to Mr. or Mrs. according to this is male, the value of the is male. Okay, so it's pretty much like the logic of the programming. Okay, it's pretty similar to the logic of a program. We program it, and also it gives a constraint of the range of the age, which you cannot do, in traditional class diagram, and also the size of the name, like how many characters in the name, right? So that's the very first example we see in the OCL, right? On Monday. And also this constraint is basically expression of the type, because every expression in the OCL is strictly type. So we have a type for this expression. So all of them are Boolean type, like the expression here. Like this has to be, this actually, if you think the return a value, this in return, it can be true or false, right? And we put this as a constraint, which means we want all this to be true in the system. Okay. Like here I mentioned strong typed. So each OCL expression has a type and evaluates to a value, to an object, or to an object within the system. Okay. So constraint is also value Boolean, like this constraints. Okay, and here are some okay, so declarative, it means something like you declare those maybe variables, those things you want to use, like you declare those variables, declare the type, or declare the type of the variable, something like that. So that's similar to a programming language. And type is also similar to object-oriented programming languages like Java, if you think about Java. Okay, and we can use the OCL in the UML models to put invariants, precondition, postcondition, guard, which is the constraint on the transition from one state to another. We will see that in a state diagram. Yeah, and invariance is the constraint on a class or type that must always hold, like those, like this age, title, name. Those are all invariants. Okay, remember, those are invariants. And also we know what are postconditions and preconditions. Okay, so that's the places we can use OCL in UML, right? Yeah, so like similar to programming language, it has the predefined types, and we can define our own types in OCL. Right? Like we can declare a class, some variable, some object is of the type of that class, things like that. Think about programming, think about object-oriented programming. Okay, but it's okay, programming is the most formal specification compared with this level. It's more formal than this level. Okay, but this level, yeah, don't get confused. Why we want this OCL thing here? You see, it's pretty similar to a programming, right? But it's not natural language specification. The reason we want this here is we want it to be understood by both human and the computers, right? So that we may reach all the benefits like automated programming and facilitate the communication within a group, because this can be easily understood by human as well. Like this, everyone should be able to understand those constraints, right? It's nothing difficult. Okay. We have predefined types like integer, real, which is similar to the double and the float in the programming language, right? String, boolean, and collection. Set and sequence. What are the differences? Remember, set and sequence. Set and sequence. Difference between set and sequence.
Set, you don't care about the order. Sequence, you do care about the order.
Yes, exactly. I mentioned that on Monday. Yeah, set do not have orders, but sequence does. Okay. With 2, 3, 3, 2. If you see that's a set, you can list the element like 2, 3, 3, 2. It doesn't matter because it's a set. However, 2, 3 and 3, 2, if those are sequences, those are two different sequences. Okay. User-defined models, types, and context of OCL. Okay. So when we are talking about this context, that means from which viewpoint. Okay, so sometimes, most of the time, in the class diagram we have more than one classes, right? So this is, we have only one customer, but sometimes we have another class, maybe the shop or the brand or the store, those other types. So when you are doing this in the when you're doing the OCL specification expression, put those constraints in this class diagram. You want to clearly specify this context, like from which point of view are you doing this specification, and you use this context customer to restrict what you want to from that viewpoint, and you use this self to refer to this class, okay, like this in Java. So here we're in the context of a customer, and we won't put a string there. We want every customer to be have the age between 18 and 66. Between 18 and 66. So we use this INV. This means invariance. Okay, remember invariance, post condition, precondition, and guard. Okay, so this is invariance, which posts those strings to a class diagram. Okay, so this should be easy to understand, and we use and is instead of conjunction, so which make more sense or make it easier to understand. Okay, so that's a good thing about OCL. And here are some operations for those types we can use in the expression. Pretty much the similar thing we would like to use in or the specification or those predicates. And also some Boolean type, like the logic thing, equal, not equal, or, XOR, something like this. And this if then else. We have used most of them, right? Okay. And for a string, we have some other operation like connect to strings, get a size of the string, to lower to uppercase, something like this. Those operations are already being predefined for you. You do not have to define that again. like there are some functions in C++. Okay, in Java you can have a array. You can dot length or size. I forgot length. I guess you can have the length of the array, right? Something like that. But if you want to do something else to the string, you can define your own method. Okay, and then it's the collection type in the OCL. Let's see what here. Oh yeah. So a collection evaluates to the object stored in A. So if we have a class and we're in that class, we're in the context of the class C, and that class have an attribute A. So self.A will evaluate to an object, and however, if we have a one-to-many association to another class D, so C with D, like classroom, students. Okay, C is classroom, D is student. So one classroom is associated with many students. Okay, so like self.r1 will return a set whose elements are of the type D. Like class, we're in the context of class, and we're using self.r1. R1 means whatever the relationship, the name of the relationship. Like a classroom holds students. Okay, maybe R1 is holds. So self.holds will return the set of student. Okay, and if R1 is ordered, then a sequence is returned. That means the relationship is ordered. And if D has attribute B, then we can just use this dot to reach that B. Evaluate to the set or sequence of all the B's belong to D, because every D has the attribute B, so D is student. So D student have a, okay, every one of you have a laptop. Okay, here if B is laptop, so self classroom dot hold dot this part return the set of student, and you dot laptop, this part return a set of laptops. Okay, this is the classroom. Dot R1 means the classroom holds students, so it returns student. This will return the laptops of student or any other thing you define. Okay, so this is that association. The example. Let me skip that because we talked that last time already. Yeah, that returns a set. Which one? Okay, this is order. This is the order I mentioned. So if we want we want to specify that this relationship is ordered, okay, we have to use that brackets with the keywords ordered. Then this self.r1 will return a sequence instead of a set. Okay, so somebody can give an example of this. Ordered. Just use the classroom student, maybe yourself, as an example.
Keychain and then keys, and then one to many, and then many to one, ordered, and then you'd say self dot, and then whatever the relationship between keychain and keys. That could be chain link dot,
yeah,
or self dot chain.
Yeah, usually the keys has the order. Yeah. Okay, that's cool. Thanks. And I return the sequence. Okay, so sequence in order. It's ordered. Remember, sequence is ordered. Don't forget that. OCR functions on collection types. Okay, so for this collection types, we also have those functions. Size, of course, count, includes or excludes. I think we talk about okay, the size empty. Okay, so this is the thing. Context INV, right? Context is the count, invariant is the constraints. So self.r1 not empty means accounts customer cannot be empty. So account must be assigned to one customer at least. It's a way we specify those system constraints. Okay, this is an interesting one. The relationship between flight and person, if you still remember. So a pilot is a member of the crew. Still remember that? How can we specify that? A pilot is a member of the crew. R1 is the relationship between flight and person, which is the pilot. R2 is the crew member. R3 is the flight attendant. Okay, now we want to see I forgot. A pilot is a member of the crew, and we're using includes or the includes or function there. Okay, let me go back here a little bit. So what is includes? Includes object. If the object, let me see. It's true if the object is an element of the collection, right? So what we want to do is pilot is a member of the crew, so we will use the includes function. Let's see how to do that. First, you choose the context. You choose the context. Okay. You choose the context. Wait, what is the context? Okay, so there are only two options, right? Flight or person. Right? Flight, a person. Yes, exactly. Because we want to get different relationship. All those relationships are somewhat related to the flight. It's different rules on that flight, right? So the center basically is the flight. So if we want to see okay, a pilot is a member of the crew, we choose the context as flight, and we use the self. The invariant is self.r2 includes self.r1. Don't forget the arrow. It's for the function. Okay, R2 includes R1. It's R2 because it's .R2. It will return a set of crew member, right? And R2 includes R1 means the set includes the pilot. Okay, and next one, all flight attendants are also crew members. So first, let's select the context. Let's select the context. Still flight, right? Yeah. And self.r2 includes or self.r3. Right. What's the difference between includes and includes or? Includes, we have an object as a parameter. Includes or, we can have a collection. it can be a set, right? So this is we want self.r2 includes all the members of self.r3. Self.r3 returns all the attendants. Self.r2 returns all the crew members of that flight. Okay, now let's think about something else. Can we solve this problem with like a pilot is a member of the crew? Can we solve this with the context, if we select the context as person instead of flight? Can we do that? A pilot is a member of the crew.
No, because you need a pilot for flight. Pilot's the third. Person can be fireman.
Yeah. If you want to specify something about the flight, then you might be able to use the context as a person, right? Like yeah, let's find another example. Maybe this is not a good example. Okay. But I mean, you do not have to always select something the same context at all the time, right? Because you have the flexibility, you have the options to freely select account or customer as your context to specify whatever you want to say. That's a.
So what is the criteria for selecting the context?
Criteria?
Yes.
I don't think there's actually formal defined criteria there. So it just for this situation, you cannot just select a customer because you cannot finish that job with that context, right? Because you cannot use a context of customer to specify each. You cannot select the context of the flight, the person, to specify a pilot is a member of the crew here. However, if we have some other structure here, like we have a person, and then we have some subclasses as a pilot, we have subclass crew member, we have subclass like flight attendant, then we may be able to select some other context. So this, if you can achieve what you want to specify with any of the context, you can freely select one of them. But there are some situations like this one, you cannot do it with the context of person. So you have to select the context of the flight, right? Yeah, that's like the way you're talking. You're asking, like, is there any criteria I should give a lecture this way or that way? There's no such a criteria actually. Yeah, but there are some good practice, like this one, like this one. It's talking about the person. It's talking about different kinds of person. All of those persons are associated with the flight, right? So you use the flight as a context. And also, this is actually okay. This usually it's if you see here, let's see it's here. We have a specified relationship of one to many, or one to many to, well, many to many functionality. If you see anything like always one to many, like a classroom 106, it's associated with many students, many instructors, many courses, then most of the time, if you want to specify the relationship between this structure, between this among this instructor, student, and courses, you want to select this classroom as your context. It's like where do you context is like where do you stand? You stand on this point of view, and you are specify the relationship of my stuff, right? If I want to specify the relationship between my shirt and my computer and my book, so you don't want to select a point of view from this book, right? You select me as the context because everything else is associated with me, and I'm specifies the relationship between these things, right?
Excuse me, sir. In this situation, person is a pilot.
What?
It has many to many as a relation.
Pilot is one-to-one. Why? Here, pilots one is one-to-one. Because one flight can only have one pilot, right? Okay, let me give you another example. Let me think about it. So since we have a person-flight relationship here, crew member, person, flight, flight. This is not a good example. Okay, so if we want to say, because sometimes if you are a pilot of one flight, right? If you are a pilot of one flight, and at the same time, you are well, if you are a pilot of the flight, which means you are actually one of the crew members of that flight as well, right? That's true, right? Because the crew members include the flight. So if we want to specify, that doesn't make sense, but if we want to specify if a person is a pilot is driving the same flight if you want to say something like this, I mean, a person is driving the same flight in which he is a crew member. You know what I mean? You know the meaning of this sentence? Yeah, it's kind of tricky. Okay, let me figure out another. No, I have to stick to this example. A pilot is driving the same flight in which let's see, he's also a crew member. Just this one. Okay, then we are able to select the context of a person. Right, and then we have the invariants like self dot r1 which returns the flight, right? Which returns the flight, and then we'll use this use this equal. Then this is maybe a poor example, but the point is there. If we want to specify this thing which in the center of the pilot, as a center, standing on the viewpoint of a person, of a pilot, then we can select the pilot as the context. Okay. Okay, that's the point. Okay, then we talk about select, reject, collect, and the sum, which are all the sum operations of the collection as well. Okay, so what is select? So select means you create a sub collection that contains the objects that satisfy the conditions. Okay, like you select all the students whose age is above 20, something like that. Okay, so that's select. If you have know what is the SQL language, something like that, things like that. Okay, reject is it creates a sub collection. From this collection, you create a sub collection that contains object do not satisfy the condition. Okay, do not satisfy the condition. So if you use a condition like age greater than 20, it will return a sub collection from that collection. The members of that sub collection, they meet the condition that they don't meet the condition greater than 20, which means they're younger than 20. Okay, like we exclude something, we remove something from that collection, we remove all the students above 20, something like that. And collection sum returns the sum of the elements of the collection. These elements must be numerical. Yeah, just you sum something up. And in collection collect, you need to give one of the attribute of the object as the parameter, so that you create a collection of equal size with the object containing the attributes specified. Okay. Let's see some example, then we know what are those. Okay. So we have two classes. One is the account, one is the transaction. It's one to many relation, R1. Okay, because the account can have a whole bunch of transactions. And assume we are in the context of account, and let's see what is returned by each of the following. Okay. Okay. So this self.r1 select value greater than. Okay, the transaction has a value. Okay, transaction value, which is an integer. Okay, which transaction value? It can be some amount change in your account, so it has a value there, right? So okay, so self.r1 select value greater than 500. What will that return? What was that? Values? It's not returning any values. It's return. It's not return number.
It's returning accounts, right?
No, it's not returning account.
Transaction.
Yeah, it's returning transactions. It's returning a set of transactions. Yes. because we are in the context of account, right? So self is referring to account. Self.r1 is self.r1 will refers to a collection which is connected with self in the relationship of R1. Okay, so self.r1 will return you a set of transactions. Okay, will return a set of transactions, and among this set of transactions, we use a select operation to put some constraint on that set. Then we create a subset of it. So how do we put that? Is we put the constraint, the condition of a value greater than 500. So it will create a subset which include all the transactions, and for all these transactions their value is greater than 500. Okay, clear? Right. So we have a whole bunch of transactions in our bank account, and now we want to see all those transactions have the value greater than 500, because I want to see what do I do for those maybe big transactions. Okay, so we use the select. And self.r1 reject value greater than 500. What will that return?
Return everything under, or to 500.
Yeah, to 500, up to 500. It will return a subset which includes all the transactions less than 500, less or equal to 500. Okay, and sum. Okay, self.r1 dot value sum. We didn't say self.r1 sum because we cannot just sum the transaction, right? We have to sum the value of the transaction. Got me? Okay. This part, self.r1, this part returns a set of transaction. Self.r1.value returns a set of value. Okay, only this will return a set of value which is integer specified in the class diagram. This returns an integer. And so for this subset, for this collection, if we sum them up, what does that mean?
Sum of all the transactions.
No. It's not sum of all the transactions.
It's the sum of all the integers.
Yeah, it's a sum of all the values of each transaction. You cannot sum transaction. You can only sum the value of the transaction, right? Because transaction has maybe it's not writing there, but maybe it's not specified there. Transaction may have a date, place, value, right? You cannot just sum all those dates, right? Dates of the transaction, place of the transaction, or what is the other account of the transaction? Like you're transferring money from one account to another account. Maybe that information may be all included in that transaction. Or maybe if it's more better system, it has your signature or something like that. Okay. However, here's sum. We can only sum a number. It can be real number, integer, something like that. You can only sum those numerical values together. Okay. So it's a sum of all the values, right? It's a sum of all the values. So basically, it should be a balance of the count. Do you think so? Right? It should be the balance of the count if you sum all the values. Because if it's money coming in, it's going to be positive number. If the money you paid, it's going to be a negative number. And then if you sum all of them together, it should be a balance, a current balance, I guess. Yeah. Yes. Yes. Yeah. Okay. And next, self R1. Then we sum self R1 collect value. Okay, this is more complicated. So what does that mean? Transactions. Okay.
You're taking a subset of the values that were collected and summing them.
Yeah, we have this self R1 collect value. So this what this return? It's
should be
similar to this, right? So
yeah, it should be whatever was purchased or you collected money and not the returned items that you gave out. Then the deposit values.
basically it returns it returns the sum of all the transaction values which equals to some certain value. Let's see if there's any explanation there. Okay. See. So this is used to collect. So collect object attributes. It creates a collection of equal sides with the objects containing the attributes specified. Okay. So it returns, the self.r1 returns a whole bunch of transactions which contains some certain value. Okay, some certain value. And then it sum this value up. Like you give some certain value like 10. Like how many tens have you maybe this is 0, you spend 10 in the morning, 10 in the afternoon, and then it will create a set of 2 transactions which is at 10. Okay, something like that, and you sum the value. Okay. And here for OR expression. So what is the keywords for OR? It basically evaluating some expression on every element of a collection. So the syntax is a collection for OR, arrow for OR, Boolean expression. Boolean expression means some expression that returns Boolean value, usually like greater or equal to something like that will return Boolean, right? So this is an example. We have a count, we have a customer. Okay, so it's many-to-many relations. If we are standing in the context of a count, okay, and the invariant is self.r1, which refers to a whole bunch of a customer. Okay, and for R, name equal to Jake. So what does this expression mean? Evaluating expression on every element of a collection. just return all the customers whose name is there's only one name there. Come on. Whose name can only be Jack, right? Okay. And here for OR with two variables. Okay, we're still using the context as the account. Okay, so here we have self.r1, but we have two variables, e1 and e2. They are all of the type customer. Okay, and e1, e2 implies ID. So this means not equal to. Okay, this means not equal to. So we're specifying that. For every customer, they have a identical. No, they have a different ID. Their ID are different. Okay. That's basically we're specifying that. Okay, then adding preconditions and postconditions to operations. So preconditions is the predicates. Remember what that predicates. Associated with a specific operation must be true before the operation is invoked. Postcondition is the other way. It must be true after the operation is invoked. And both those conditions are associated with some sort of operation. Like here, okay. Pre and post condition for this customer class, we have name, address, age are as the attributes, and we have set age, get age method there. Okay, so here context is customer, and we want to specify the precondition and the post condition for a operation, right? It's not a precondition and the post condition for a class. Therefore, here we have not only customer, but we also have one of the method in customer, which is set age. Set age. Okay. And then we have a, which is integer, which is specified here as well in the class diagram. We have integer as a parameter. Then we want to specify the precondition for this is the age. When we set the age, the parameters we give to that operation, to the function, to the method, set age, should greater than 1. And the post condition is age equal to age at pre plus 1. So at pre is basically the. So before, if you think, try to think about something we mentioned last several weeks ago. We're using like a prime to express the value after the operation, right? But here, no, we are not using the prime, so we're using age. We're always using age, but we give this at pre to specify this is the value before the operation. Okay, this is the value before the operation. Yeah. So to indicate that we are referring to value at the start of an operation. Okay, maybe this function doesn't make sense because if you set age, you give an age and you didn't set age there. Yeah, maybe this is not a good example. I don't think this is a good example. But remember this thing: age at pre is the value of age in the beginning. Okay, in the beginning of this operation. I think we should modify this. Set age. This is okay. I don't know. Trying to find this. That's fine. Yeah, let's see some other example. I want to modify this one. Maybe we can have another method called increase the age. Maybe every year, if you have system, every year when you register, you give a name, you give age, the initial age there, and every year after your birthday, it will automatically increase your age by 1, right? Add your age by 1. So that's what this post condition did, right? But here it's not a good example. Here it's better to say age equal to A instead of this. But we can see okay. If we do want to say this make more sense, and we can do something else if we want to use the at age. We can say name equal to name at pre, because we want to make sure this operation doesn't change anything else. Okay, this makes more sense to me. All right. Okay, the return keyword. The keyword return, it returns some value, just simple. It define in the most of the time maybe in the post condition, because in post condition you're going to return something after the execution. So in the post condition indicates the return value of an operation. Here, customer get age. Get age. It's the and you specify the return value type, return type of the get age is integer, and get age is a method of customer. Right here, customer has this get age function. So here we are in this method, we're in this operation, and then we specify a post condition, which is return is self.age, right? Self.age will return that age, right? Okay. And then okay, OC, what type of boolean? It's this two, type of, OCLS type of, OCLS kind of. It's related to, it's also a boolean, and the type of is true if the type of self and T are of the same type. You give a type and to test if a flight is a flight, something like that, if a person is a person. Okay, and Okay, here, if you're in the context account, so you want to test if self is of the type account, then it will return true, right? But if you are trying to test if account is a customer, then it's gonna be false. Okay. Okay, and kinds of it's gonna be some subclasses. You can also test subclasses, like a person. If you want to test if a student is a person, if a teacher is a person, if the staff is a person, right? If they are all inherited from the person, so it will return true. Okay, so like it's going to be true if either the direct type or one of the subtypes of an object. Okay, if you want to test if a person is a person, it's going to be true. If you want to test if a student is a person, it's going to return true. If you want to test teacher is a person, it's going to return true. Okay, it depends on how you define the class and its subclasses. Okay, so everyone up here learned what is object-oriented programming, right? Okay, so that's not a problem here. Alright, so that's basically you are trying to test the type. You are trying to evaluate the type, if that of the same type. Okay, here's the case study. Here we have a house, we have a class house, we have a class person, mortgage, yeah, and then try to write the constraints. Okay, let's try to pick some of them. Let's try the first one. The start date for any mortgage must be before the end date. Okay, because I'm giving you this class diagram. Now we want to extend this class diagram with the OCL, and we want to specify first the start date of any mortgage must be before the end date. Okay, start date of any mortgage must be before the end date. Isn't that easy? What is the context?
Mortgage.
Yeah, we can just select mortgage because that's nothing to do. For now, it has not. For that specification, it has nothing to do with house, person. It's only constrained within that mortgage. So we select context as mortgage, right? And then we use self dot start date less than self dot end date. And that's it. That's invariance. Okay. Context mortgage invariant self dot start date self dot end date. Okay, let's find a more complex one. Okay, second one. A person may have a mortgage on a house only if that house is owned by himself or herself. One cannot get a mortgage on the house of one's neighbor or friend, right? Of course. So you can only have mortgage on your house. Basically, let's specify this. A person, let me read this again. A person may have a mortgage on a house only if that house is owned by himself or herself. Okay, let's see. Let's select the context here.
Wouldn't it be person?
Yeah, I think it's gonna be the person. Yeah. So let's say it's a person. Context is the person. Okay. Variant.
And then it would be self dot social security number.
Social security number.
Yeah, I was trying to say like two social security numbers can't be the same, so you would use this.
No, we want the social security. You don't want social security to be the same. We're not using social security actually here. So let me give you some answer here. So because we don't have a lot of time, we can do the rest in the next class. Self.r3. Self.r3, right? Dot r2. Is that gonna be the house, right? It's gonna be that house, right? Well, let's see, self dot r1. Okay, so this kind of makes sure the two house is the same house, the mortgage house and your own, the house you own. However, it's actually one too many. It's one too many. We cannot just reach that house, but dot. So let's think about what we can do, and we will talk about it next class. Right? All right, thank you.